Here we will graph lines in point-slope form. That is, lines of the form y equals m times the quantity x minus x naught plus y naught. All right, so in this form, it's a little different than y equals mx plus b, isn't it? But it comes from the formula for slope, actually. Like if you took this equation just as it sits and you subtracted y naught from both sides and divided both sides by x minus x naught, you'd essentially get the formula for slope, right? Difference in y over difference in x. So that's where it comes from. Now, in this case, m is the slope, right? Both in point slope form and in slope intercept form. M is the slope. And x naught, y naught is a point, right, on the graph of the equation. Okay, so keeping that in mind, basically the only difference between graphing something in point slope form and graphing something in slope intercept form is that slope intercept form gives you a y-intercept and point slope form gives you a point. That's probably not the y-intercept. So the directions here are to graph the following equations by identifying the slope and one point on the line. Okay, so this first example of y equals negative 3/2 times the quantity x minus 1 plus 5. Okay, so the slope is negative 3/2, just looking at the equation there. And the point that we're looking for is 1, 5, right? That's the x naught, y naught that's there. Okay, so let's use what we know about these two things to graph this line. All right, so the first thing I'm going to do is plot the point that we're given there, 1, 5. Where is 1, 5? Here we go. Okay, so we'll plot that point and then use the slope. Now the slope is negative 3/2, all right? So because it's negative, instead of being a rise over run, we're going to fall over run, right? So from this point of 1, 5 that we're given, we're going to fall 3 units and run over 2 units, like so, right? So I'm going to do that again. I'm going to fall 3 units and run over 2 units. Okay, that's all we need, but we can keep going, right? You can do this as many times as you like. Down 3 over 2. Okay, all right, so we've got the dots connected there. And so this is the graph of the line y equal negative 3/2 times the quantity x minus 1 plus 5. Okay, so for this next example, we have y equal 4 times the quantity x plus 3 minus 2. Okay, so looking at the equation, the slope is 4, and the point that we're looking for, now careful here. So if you look at the general form for the slope, point slope form, you have m times the quantity x minus x naught plus y naught, and here we have x plus 3. So you want to think about that as inside here as like a x minus negative 3, like that, right? Because we're really thinking about that general point slope form as having a negative there. So if we subtract a negative, we'll get a positive. So the point in question here is actually negative 3, negative 2, right? Because the y value in the original form is plus y naught, and we have a minus 2 here. So negative 3, negative 2 would be our point. Okay, so I'm going to plot negative 3, negative 2, right, as our x and y values there. And now I'm going to use the slope of 4 to find some other points. So from that point of negative 3, negative 2, I'm going to rise up 4. So remember, it's rise over run. And when you have an integer value here for a slope, remember you can have 4 over 1. So you're rising up 4 and running over 1, right? Rise up 4 and run over 1. Yes, okay. So we've done this. We could do it as many times as we like, but we're running out of room here. Okay, so these are all points on the graph of this. And as I connect the dots there, we get the straight line we're looking for. And again, I did an example here with a negative slope in the first example, and in the second example we have a positive slope, so we see the difference between a decreasing and an increasing line. Okay, good. And also worthy of note, if you're given something in point slope form and you don't recognize that you have a point and a slope, you could distribute the slope through those parentheses and combine like terms, and then you would actually have something in slope-intercept form. So just a note about that. But if you notice this point slope form, you have a point, and if you know the slope, you can find all kinds of other points using that slope.